The countdown has already started. What if the worst-case scenario is unfolding right now with 3 Atlas at its center? We're told that 3 Atlas is a natural phenomenon because that's what the data indicates. But beneath that surface certainty, a far darker theory is taking shape. What if it's not departing? What if what we assume is an exit path isn't an exit at all? Picture a probe so advanced it could disguise itself flawlessly as ice and dust, blending into the cosmos without a trace. Picture a civilization so careful it sends silent observers instead of ambassadors, machines that never announce their presence, only watch. If that's true, then 3 Atlas isn't just a comet, it's a signal, or something far more unsettling, a test. Tonight we'll step into the fragile boundary between science and speculation and uncover why October 29th may mark the comet's moment of truth. We'll pit reason against fear, evidence against unease, and confront one haunting question that refuses to fade. Is the worst-case scenario already unfolding? On the night of July 1st, 2025, a routine sky scan became a chapter in cosmic history. High in the Chilean Andes, the Atlas Observatory, built to chart faint travelers of our solar system, caught sight of something it was never meant to find. A dim point of light, nearly indistinguishable from the backdrop of stars, drifted across the detector with just enough peculiarity to draw attention. At first glance, it was nothing special, a 14th magnitude speck moving gently against the heavens. The observatory's automated system flagged it for a follow-up, just another entry among the endless swarm of asteroids and comets recorded each week. But as astronomers refined its orbit, the numbers stopped obeying familiar laws. Objects bound to the sun carved predictable ellipses. Comets stretched those paths into long, dramatic loops. Yet even the most eccentric trajectories always bend back toward their parent star, held fast by gravity's pull. This one refused. Each new observation pulled the curve farther from the known, until the truth became unavoidable. The track was not an ellipse, but a hyperbola, the unmistakable signature of something unbound. This object wasn't orbiting the sun, it was passing through, a visitor from beyond our system. Within hours, the realization raced through the global network of observatories. Emails, urgent calls, late-night scribbles on notepads. Each confirmation deepened the awe. For only the 3rd time in human history, we were witnessing an interstellar traveler. The designation arrived quickly. 3I Atlas, the 3rd of its kind, named after the telescope that first captured its light. News spread fast. Reporters scrambled for context. Oumuamua in 2017, Borisov in 2019, 2 strange visitors that had teased us with mystery before fading into the dark. But from the start, this one felt different. Its velocity, its glow, its chemical hints, all pointed to something stranger. Even before speculation took hold, the discovery carried an unmistakable gravity, a quiet wonder that reached beyond science. A faint pixel on a screen had bridged us to the vast machinery of the galaxy. Somewhere, far beyond our reach, near a forgotten star, ancient forces had flung this shard into interstellar exile. For eons, it wandered unseen until chance aligned it with a small telescope in South America, and through that lens, into human awareness. There were no fireworks, no streak across the sky. Atlas arrived quietly, as most cosmic revelations do, slipping into our data streams like a whisper. But within that whisper lay the first line of a story that could stretch our imagination to its limits. Because every interstellar object carries the same haunting question. What else drifts between the stars, and why now? Confirmation came not with spectacle, but with numbers. Precise, silent, undeniable. Across 2 nights in early July, observatories around the world turned their instruments toward the faint intruder first glimpsed by Atlas. Each telescope added more data points to the growing map of its motion. With every new dot, the truth sharpened. The orbit refused to close. Gravity could not reclaim it. What began as a suspected comet was now revealed as something far stranger, an object moving too fast on a path too straight to belong to our sun's domain. In data centers and control rooms, astronomers watched their models update in real time. Ellipses stretched open, unfolding into endless curves. The crucial number, eccentricity, climbed relentlessly. 1.01, 1.1, higher still. Anything above 1 meant freedom, escape velocity achieved. By dawn on July 3rd, the conclusion was unanimous. It was hyperbolic, it was interstellar. For the third time, the universe had sent a messenger from the deep. Oumuamua, slender and enigmatic, had startled us in 2017. 2 years later, Borisov followed, behaving like a true comet, yet born of another sun. Now Atlas had joined their ranks, carrying fresh secrets and new questions. For astronomers, the discovery was equal parts thrill and unease. Detecting one interstellar visitor felt like luck. Detecting 3 under a decade hinted at something larger, a galaxy rich with these nomads, fragments of alien worlds drifting silently through the dark. If 3 had already been noticed by chance, how many more had slipped past unseen? How many had crossed our skies before we learned to look? Press releases tried to convey the magnitude of it, but language faltered under the weight of what the data implied. A piece of another solar system had entered ours. Its icy core had formed around a distant sun billions of years ago, then been cast out by a violent encounter long forgotten. It drifted across light years, carrying within it the chemistry of its birthplace, until by cosmic coincidence, it crossed paths with our instruments and our story. There was humility in that realization. Our planet, for a fleeting moment, had become a waypoint on a journey that began before humankind and would continue long after. The object itself had no awareness, no purpose, only momentum, an ancient memory sealed in ice and dust. Yet its arrival forced us to look outward and inward. What tales do these wanderers bring from the galaxy's far corners? And perhaps more unsettling, what tales might they carry away about us? Observers, witnesses passing silently through the glow of a civilization that burns for but an instant. At first, it was nothing more than a sterile label, C/2015 N1, a string of letters and numbers neatly slotted into the database of comets. But once its interstellar nature was confirmed, the designation felt inadequate. Something that had crossed the gulf between stars deserved a name worthy of its journey. The International Astronomical Union acted quickly, following precedent. Oumuamua had been 1-eye, the first herald, its name drawn from the Hawaiian word for a messenger that arrives first. 2 years later came Borisov, or 2-eye, the second herald, marked by its discoverer's name. Now the pattern continued. The third traveler was christened 3-Eye Atlas, a title that honored both discovery and destiny. Now this new wanderer received its place in the cosmic order, 3-Eye, the third of its kind. The naming followed naturally. Atlas, the telescope whose electronic gaze first detected the faint shimmer on July 1st, was honored in the second half of the title. Together, they became 3-Eye Atlas, a name simple in form but powerful in effect. What was once a string of catalog numbers now carried story, weight, and myth. Scientists could reference it with ease, journalists could shape headlines around it, and the public could finally imagine it as something beyond a cold speck of data. Language had turned observation into narrative. Since ancient times, names have given meaning to the stars. Our ancestors saw gods, beasts, and heroes mapped into constellations, and those names shaped how generations understood the night sky. Even today, a sterile acronym can inspire awe if attached to the right discovery. To call this object Atlas was to place it among a lineage of celestial messengers, each one more than ice and dust, each one a symbol of connection across the galaxy. Speculation quickly gathered around the name. Atlas, the titan cursed to bear the heavens, lent the comet an unintended grandeur. The third messenger, people whispered on late-night forums, as though the universe were sending signals in a sequence, one every few years, each more curious than the last. Oumuamua, the first call. Borisov, the second. And now Atlas, faster, stranger, and chemically distinct from both. To many, it felt like escalation. Names outlived the objects they describe. Oumuamua has long vanished from sight. Borisov scattered into dust. Atlas, too, will fade into the dark. Yet their names remain, milestones in our growing mythology of space. What began as a practical label had already begun to transform. Atlas was no longer just a comet on a hyperbolic path. It was a symbol of contact with the wider cosmos, a reminder that even in silence, the universe speaks. And once a name is repeated enough times, it begins to feel alive, less like a discovery, more like a character in an unfolding story. Atlas was no longer passing through. It had entered our story. The first reports came swiftly, as they always do when something new crosses into our skies. Atlas was classified, logged, and neatly filed under Comet. Images showed the soft halo of gas and dust, the signature coma that blooms when sunlight warms frozen ice. Its orbit, while extraordinary, posed no threat. It would pass Earth safely at a distance of roughly 270 million kilometers. The tone of the official language was calm, methodical, reassuring. No danger, no disruption, just another traveler, the one born under unfamiliar stars. NASA's statement read almost like a sigh of relief. Yes, it was fast, yes, it was unique, but it was safe. Journalists echoed this sentiment, careful not to spark unfounded panic. After all, interstellar visitors have a habit of stirring imaginations. Oumuamua had been mistaken by some for an alien probe before vanishing quietly. Borisov had behaved exactly as a comet should. Atlas, it seemed, would follow the same rhythm, studied, cataloged, and eventually forgotten as it slipped back into the dark. For the public, it was a digestible story, a comet from another star, remarkable but not threatening. The headlines leaned into wonder, not fear. Third interstellar traveler confirmed, a harmless visitor from the stars. It was a moment to marvel, not to worry, a reminder of scale without the shadow of danger. Astronomers found comfort in its apparent normalcy. Its coma expanded as expected. The light curve, though faint, fit known patterns. Its spectrum revealed carbon dioxide and dust, odd in proportion, but not impossible. For a brief time, Atlas seemed to play by the rules. And yet, beneath that calm, unease began to surface. Its speed was unusually high, faster than any known interstellar object. Its chemical fingerprint didn't match anything in our local comets. Its skewed angle of approach hinted at origins far older than our sun. These peculiarities were tucked quietly into appendices and footnotes, noticed but not emphasized. To the world, Atlas was natural, ordinary, safe. But to those watching closely, the comfort felt fragile, because ordinary in the cosmos can dissolve into mystery overnight. NASA knew this well. When the phrase interstellar object appears in headlines, imagination ignites in ways no equation can contain. So the first briefings were careful, wrapped in the language of precision and control. No threat to Earth, they assured. Closest approach, 1.8 astronomical units, nearly twice the distance between Earth and Mars. Numbers meant to anchor, figures meant to soothe. Officials emphasized what it was and what it wasn't. Not a collision course, not a rogue asteroid, not, despite speculation, an alien craft. Atlas, they said, was a natural comet passing harmlessly through before continuing its long journey into the interstellar night. The statements leaned on familiarity. We'd seen this before. Oumuamua came and went, Borisov too, and Atlas would follow the same rhythm. The math was consistent, the models solid. The universe, though vast though it may seem, still obeyed physics, and those laws promised safety. To many, the tone felt almost like a lullaby spoken in scientific language. Numbers whispered reassurance, eccentricity greater than 1, perihelion at 1.4 AU, trajectory stable for years ahead. No surprises, no risks, no cause for alarm. This was an opportunity for study, not a warning of catastrophe. And yet, in that precision lay an unspoken tension, because certainty in space is often just the calm before discovery rewrites the story once again. The confidence was total, because it had to be. If doubt existed, it couldn't be allowed to show. The public, already trained to see danger and mystery, needed reassurance. But certainty, when faced with the unknown, is a fragile performance, one that fractures the moment truth begins to surface. Official statements sidestep the details that raised eyebrows, the strange chemistry, the overwhelming carbon dioxide readings so unlike anything observed in nearby comets. They mentioned the speed, yes, but as a curiosity, not a warning. They avoided discussing the object's sharp, tilted approach, an angle cutting steeply through the galactic plane, hinting at origins among the galaxy's ancient stellar populations. Those facts belonged in research papers, not in news headlines. For the casual audience, NASA's calm words were enough. Space was under control, safety was assured, and daily life could continue as always, even while an interstellar wanderer swept silently through the deep. But to those who listened carefully, the silences carried as much weight as the reassurances. Numbers can dismiss panic, but not the quiet unease that lingers beneath certainty. Was it truly harmless? Or was the danger not in impact, but in revelation, in what we might uncover and what we might never be able to forget? In astronomy, speed is the quiet confessor. How something moves reveals its history, where it came from, and what forces shaped it along the way. With Atlas, the math spoke louder than the images. 61 kilometers per second, more than 130,000 miles per hour. A speed that dwarfed its predecessors, nearly twice that of Oumuamua, leaving Borisov lagging far behind. At first, this was framed as another curiosity. Yes, it was fast. Yes, faster than models predicted. But interstellar space is a violent arena. Objects flung from their birth systems often bear momentum as their scar. Still, the deeper the simulations ran, the less they made sense. This wasn't random drift. This was acceleration, deliberate or not, extraordinary all the same. Planetary ejections, gravitational slingshots, close encounters with massive worlds. These can launch debris outward, yes, but not without limit. Physics imposes boundaries, even on chaos. Yet this speed seemed to exceed them. Some proposed that Atlas had passed near multiple stars, gaining energy each time like cosmic compound interest. Others speculated that its origins lay in the galaxy's thick disk, where stellar motions are older, rougher, or perhaps even beyond that, in regions of the Milky Way we scarcely understand. And in quieter circles, where cameras weren't recording, other possibilities were whispered. Was the speed random or intentional? Could such acceleration ever mimic something else, something guided? When Oumuamua passed through years earlier, one Harvard astronomer famously proposed it might be a light sail, an object propelled by starlight itself. Most dismissed the idea as provocative speculation. But now another interstellar traveler was moving even faster, and once again the math strained at the edges of credibility. NASA's public stance held firm. Natural explanations were enough. Billions of years of gravitational encounters could account for the energy. Physics remained intact, even at 61 kilometers per second. Yet behind the data and the press releases, unease lingered. Velocity leaves little room for interpretation. Something, some force or history had propelled this ancient fragment to speeds beyond expectation. Now it was here, slicing through the solar system with the precision of a cosmic blade. The problem with speed isn't just what it says about the past. It's what it implies about what comes next. At that velocity, Atlas could never be captured by the sun. It would not stay. It would pass through, flash briefly in our awareness, and vanish forever. And in that fleeting moment, humanity would have to decide. Was this simply another comet, or a messenger carrying truths we might not be ready to face? When the James Webb Space Telescope finally turned toward Atlas, astronomers expected refinement, not revelation. Spectroscopy, after all, cuts through uncertainty, splitting light into the fingerprints of molecules, revealing composition, temperature, and origin. But the story that returned was nothing anyone anticipated. The spectra showed a coma dominated not by water vapor, the essence of ordinary comets, but carbon dioxide, not marginally higher, but overwhelmingly so. An 8-to-1 ratio, rewriting everything scientists thought they knew about such bodies. On Earth, carbon dioxide is familiar, our breath, our concern, our climate ghost. In comets, it plays a minor role, detectable, yes, but always secondary to water ice. Water, warmed by sunlight, is what makes comets shine. CO2 is usually a trace, a supporting presence. Until now. The lab data was met first with disbelief, then silence, then the careful kind of double-checking that betrays quiet alarm. Could the readings be wrong? Were the instruments misaligned? Recalibration confirmed the truth. The ratio held firm. Atlas was exhaling carbon dioxide in quantities that defied logic. Impossible for something drifting through interstellar space for eons. Theories rushed into the void to fill it. Perhaps it formed near a distant star's CO2 snowline, where ice chemistry favors carbon dioxide over water. Maybe cosmic radiation had altered its surface, sealing the water beneath an ancient crust, while letting CO2 escape. Another idea suggested a dusty mantle insulating the ice below, allowing CO2 to seep out while keeping water frozen within. Each idea was plausible, each elegant, yet none fully satisfied. The oddity wasn't only in the chemistry, but in the timing. At over 3 astronomical units from the sun, where most comets remain dormant, Atlas was already awake, already venting gas in defiance of expectation, as if it couldn't wait, as if something deeper had stirred it long before the usual warmth arrived. Publicly, NASA described it as unusual but informative, a glimpse into alien planetary formation, a chance to study frozen material from another sun. But privately, scientists wondered whether the mystery pointed to something more profound. Why this much carbon dioxide? Why this early activity? Why now? The human mind, always searching for meaning, couldn't help but drift toward the unsettling possibilities.
What if its chemistry wasn't a remnant of deep time at all, but the trace of intent? What if the ratios weren't random mixtures, but deliberate signals disguised as molecules? The idea was swiftly brushed aside in official reports, yet it lingered, like faint interference on a dying transmission. In the end, the mystery of its composition left only questions behind. Atlas was no longer just fast, nor merely strange in motion. It was chemically foreign, a kind of alienness no comet had ever shown before. And as it drew closer to the sun, astronomers understood that the real story was only beginning. Silence in space is never truly silent. Every star hums, every planet murmurs, every comet crackles with the faint static of physics. The void, contrary to its reputation, is alive with energy and sound. So when the great radio arrays turned their dishes toward Atlas, scientists expected at least a whisper, the hiss of vaporizing ice, the sputtering of ions meeting solar wind, the natural noise of matter under starlight. Instead, they heard nothing unusual. No narrowband tones, no modulated rhythms, no pulse hinting at structure. Just the flat background murmur of a comet doing what comets do. Officially, this became the perfect reassurance. No message, no beacon, no engineered transmission hidden in the static. Silence, therefore, was proof of normality. But for those who live in the margins of speculation, silence is never absence. Sometimes, silence is the message. For decades, the dark forest idea has haunted the search for extraterrestrial intelligence, the notion that advanced civilizations might stay quiet, hiding from predators that hunt through the galactic dark. In such a universe, silence is survival, a strategy, not a void. And if Atlas were not a rock, but a construct, what better camouflage could exist than imitation? A comet behaving perfectly like a comet, speaking only in the static of dust and gas, would slip past every listening ear. Still, silence resists easy interpretation. Was it choice or coincidence? The data from scanning arrays reported only broadband noise, nothing that broke the pattern of nature. But perfect imitation is the simplest disguise. If an advanced probe wished to vanish among the ordinary, it would emulate randomness so precisely that no instrument could betray it. Then comes the unsettling question: intent. If silence is chosen, it implies awareness. Awareness of us, of our reach, of the danger of being noticed. But if silence is built in, woven so deeply into design that even suspicion finds no edge to hold, then maybe the signal isn't in what's heard, but in what refuses to be. The world's observatories did their due diligence. Dozens of arrays listened. The giant dishes of the Deep Space Network, private SETI experiments, even backyard receivers hungry for discovery, all agreed. Atlas was quiet. Quiet the way ancient ice is quiet, the way drifting debris is quiet. And yet that stillness rang louder than any sound. It was complete, almost rehearsed, as if the object had auditioned for normalcy and passed flawlessly. Because if something wished to stay hidden, what better mask could it wear than the one we already expect? Every orbit tells a story long before chemistry or images can. The path of a visitor from beyond is a fossil of gravity, a record of the encounters that shaped it across uncounted ages. When astronomers plotted Atlas's route, they found something disquieting in its geometry. Most interstellar objects arrive within the flat, ordered flow of the galaxy's thin disk, the same broad rotation followed by our own sun. But Atlas came from an angle few had seen before. It cut across the sky like a trespasser, tilted, skewed, out of step with everything nearby. That pointed toward the thick disk, an older, rougher layer of the Milky Way, a population of stars and debris predating the spiral arms, predating even many of the metals that built Earth itself. If Atlas came from there, it was not merely interstellar, it was intertemporal, a relic from an epoch when galaxies still collided and chaos shaped the stars. Excitement and unease followed in equal measure. Excitement because a thick disk origin meant Atlas carried the frozen chemistry of a galaxy we no longer live in. Unease because such an origin meant age beyond comfort. Could something so fragile have survived billions of years of collisions, radiation, and gravitational storms without being pulverized? Its orbit whispered an answer. This was no recent wanderer. Simulations deepened the mystery. Were other interstellar bodies traced back to plausible birth systems? Atlas resisted such lineage. Its trajectory fit nothing familiar, as if it had crossed space on its own schedule, ignoring the galactic current like a relic adrift between epochs. For many, that was enough. The orbit confirmed the chemistry. Atlas was ancient, a survivor of a time when the Milky Way was still raw. But to others, the path felt too perfect, as though chosen to slip quietly through regions where few telescopes watch. NASA stayed with natural causes, orbital scattering, chance encounters, statistical coincidence. Yet the odd tilt of its arrival hung in the collective imagination like a riddle, not threatening, not fully explained, but undeniably wrong. A single curve against the backdrop of stars, suggesting a story older and stranger than we've dared to tell. Every comet has its reckoning, a moment when it nears the sun and either blazes into brilliance or dissolves into nothing. For Atlas, that date was marked almost immediately, October 29th, 2025. A deadline written in light, a countdown not only to a physical turning point, but to a revelation. Perihelion, the closest approach, would strip away disguise and decide what Atlas truly was. Heat, merciless, indifferent, would soon test whatever secrets had been sealed within this wandering body of ice and dust. Observatories across the world had been preparing for months. Ground-based telescopes were aligned to trace the brightening halo as sunlight turned frozen gases into vapor. Hubble stood ready to capture the spectacle as long as Earth's atmosphere would permit. The James Webb Telescope, stationed in the void, would watch with its instruments tuned to catch the faintest signatures of escaping molecules. Even backyard astronomers were waiting, eager for the tiny blur in their viewfinders to bloom into something alive against the dark. Anticipation filled the air, not from fear, but from curiosity, because perihelion is a test, a moment of truth. Would this visitor flare into brilliance, casting trails of dust like banners across the night sky? Or would it crumble under the stress of sunlight and gravity, disintegrating into a silent cloud of fragments? For most comets, either fate is possible, but for Atlas, the uncertainty felt heavier. Its makeup was already strange, its orbit unsettling. What would happen when it finally faced the full fire of the sun, a warmth it hadn't known for billions of years? Some imagined that heat might unseal hidden layers of ice, shifting its chemical balance and telling a deeper story. Others believed the CO2 dominance might intensify, flooding space with carbon in quantities never witnessed before. And then there were the dreamers, those who whispered that warmth might wake something dormant, a system long asleep beneath the crust, waiting for sunlight as a signal to rise. NASA, as always, spoke calmly and carefully. There was no threat to Earth, they said. The object's closest approach would still keep it more than 1 astronomical unit away. But even in official statements, there was a hint of wonder. The data, they admitted, might rewrite what we know. As the calendar crept closer, it no longer felt like waiting for a comet. It felt like waiting for something to arrive. Every night, the stars seemed to hold their breath. Scientists sharpened their instruments. Journalists drafted headlines. Even the casual stargazer began to ask, what happens when it starts to burn? Because whenever ancient ice meets new sunlight, something always changes. The question wasn't if Atlas would reveal itself, it was what it would choose to reveal. And the countdown had already begun. Hyperbolic orbits offer comfort through simplicity. They promise a one-time encounter, a quick approach, a swing around the sun, and then an exit into the dark, never to return. That was the reassurance when Atlas was first discovered. Its path was clear, its speed too high for capture. But reassurance fades quickly when imagination takes hold. What if departure isn't departure at all? What if slowing down is the goal? In celestial mechanics, speed decides everything. Too fast and you escape forever. Too slow and you fall into orbit. What if somehow Atlas carried the means, natural or otherwise, to adjust its velocity just enough to stay? The sun, after all, doesn't only launch, it can also slow. For human spacecraft, slingshot maneuvers are routine. What if for something older and far more capable, stars themselves are used as brakes? There is no proof of such intent. Every reading aligns perfectly with the profile of a natural visitor on its way out. And yet, that precision itself feels unnatural. Objects formed in chaos usually carry scars, small irregularities in motion, tiny deviations in path. But Atlas glided perfectly, as though rehearsed. If someone wanted to fake nature, would it look any different from this? The danger isn't collision, it's permanence. What if its true plan was to stay? To drift quietly into the Kuiper belt, lost among countless other fragments, never leaving, yet never noticed again. There would be no signal, no change in trajectory, no grand reveal, only the faint act of slowing down while pretending to depart. Sometimes the best disguise is to seem like you're leaving, and then simply remain. NASA dismissed such thoughts, confident in the math, and maybe they're right. Gravity doesn't lie. But the possibility lingers, like static at the edge of thought. Because when our models of nature are perfect, anything that wishes to blend in only needs to be equally precise. So the question shifts from evidence to imagination. What if Atlas isn't a transient visitor at all? What if the flyby is already over, and what we're witnessing is its quiet arrival? Nature, after all, makes the perfect camouflage. To hide in plain sight among comets and asteroids requires no invisibility cloak, just imitation. For a civilization that could cross the stars, wrapping machinery in ice and dust would be effortless. Atlas, with its carbon-rich coma and unpredictable glow, could be the perfect example of such mimicry. Comets are chaotic by nature. They flare, fracture, and fade in ways no model can fully predict. Their chemical signature is very wildly, and their behavior defies consistency. So when Atlas showed an odd carbon-heavy spectrum, scientists were puzzled, but not alarmed. Because comets should surprise us, that's what makes them believable. If one wished to hide technology beneath a natural shell, the method would be simple. Wrap it in ice, cover it in dust. Make sure every reaction, every burst of gas, every spectral reading matches the chaos we expect. Let the anomalies be just strange enough to seem natural. From the outside, everything looks ordinary. Only a whisper of doubt remains. The idea that something artificial might wear the mask of a comet is not new. Thinkers and scientists have long pondered whether silent messengers, probes hidden in the debris of creation, might already be drifting among us. And perhaps, just perhaps, one of them now approaches the sun.
Observers scattered across the stars might all wear the disguise of something ordinary. The art would lie not in spectacle, but in subtlety, not in shining beacons or towering constructs, but in chemistry tuned to vanish into cosmic background noise. If something like Atlas were an example, then it played the role flawlessly. Its velocity, though remarkable, sits neatly within what one expects of an object cast adrift between stars. Its orbit follows the pure mathematical curve of a hyperbola. Its faint glow behaves just as the models predict when sunlight stirs frozen gases from slumber. Every test, every observation, insists it is precisely what it seems, a comet. And yet, that very perfection feels uncanny. For what better camouflage could intelligence choose than perfect imitation of nature itself? NASA, cautious as always, holds to the natural explanation, and the numbers agree. Still, the silence, the unusual composition, the flawless mimicry, all leave the faintest thread of doubt. If alien craft wished to vanish, they would not do so in steel or circuitry, but in dust and ice. Not by standing apart from nature, but by becoming indistinguishable from it. And so Atlas drifts through the gaze of our instruments, every measurement confirming its normalcy, every confirmation deepening the irony. Because perhaps the greatest trick is not concealment, but how easily the ordinary can wear the mask of the extraordinary. Imagine a civilization so old, so patient, that its scouts do not arrive in shimmering ships, but drift silently as comets, the most unremarkable shapes in the heavens. To our eyes, they are harmless nomads, frozen mixtures sculpted by light. To another intelligence, they could be the perfect observers, sliding unnoticed through planetary systems beneath a cloak of natural debris. This is the unsettling premise known as the surveillance hypothesis, the idea that some visitors from interstellar space are not random travelers, but deliberate placements. Comets, after all, are everywhere, spawned from the Oort cloud, the Kuiper belt, the scattered disk. They are common, messy, and ignored. When astronomers find one tracing a strange path, the instinct is to catalog, not to question. What disguise could be safer for a probe than an object we already expect to find? Atlas fits this speculation with unnerving precision. Its path through space aligns perfectly with what a genuine interstellar wanderer should trace. Its incredible speed, while dramatic, remains within physical limits. Its halo reacts predictably to solar heat, releasing vapors as any comet would. Everything about it says natural, and yet its chemistry refuses to sit quietly within that narrative. Where most comets sing of water and trace gases, Atlas speaks almost entirely in carbon dioxide, an odd ratio that hints at something stranger. To most researchers, this is an enigma of birth conditions. To a few, it whispers of intent. If one wanted to hide instruments, sensors, or dormant mechanisms, why not shroud them in exotic ice, the kind that already produces anomalies nature can easily excuse? The logic is chillingly sound. Launch countless disguised observers, scatter them across the galaxy, and wait. Some will perish, others drift away, but a few will find themselves inside young systems like ours. There, unseen and unannounced, they can watch, listen, and record. To us, they remain comets. To them, we are data. Of course, the official record points toward the ordinary.
No artificial signals, no erratic movement. Every wobble of its orbit explained by gentle jets of vapor. Still, absence of evidence is not evidence of absence. An advanced probe would have no reason to betray its presence. Its very purpose would depend on invisibility, on blending into the hum of the cosmos itself. The surveillance hypothesis, then, is not an accusation. It's a provocation. It challenges the quiet arrogance that assumes everything we see must be natural. Not every visitor needs a grand entrance. Some might prefer silence measured in millennia. As Atlas loops around the sun and drifts back into the dark, the question lingers like static beneath the data. Was this simply a comet, or something that has been watching us all along? Astronomy, after all, is a kind of reading, chemistry as its language. Every spectral line a syllable, every molecular ratio a word in the biography of a celestial body. When light strikes frozen dust and vapor escape, it writes messages in color and wavelength. Most comets tell familiar tales, water abundant, with whispers of methane, ammonia, and carbon monoxide. Atlas tells a different story. Its spectrum is almost entirely carbon dioxide, a grammar that sounds foreign, a dialect no one has seen before. The simple explanations remain. Perhaps it formed far beyond its star, in the deep cold, where CO2 froze freely, or maybe cosmic radiation hardened its crest, sealing in water while letting CO2 escape. Plausible, natural, and yet that doubt persists. What if such chemistry isn't an accident, but a kind of signal? To encode information in chemistry itself would be genius. Radio transmissions can be intercepted, metallic probes can be photographed, but chemical ratios hide in plain sight, masquerading as random variation. Astronomers expect oddities. They're part of the game. What if someone used that expectation as camouflage? Picture a civilization that thinks not in centuries, but in eons. It seeds the galaxy with frozen messengers, each one carrying patterns designed to survive time. Perhaps the ratio of CO2 to H2O forms a code. Patterns too orderly to be coincidence, too subtle to raise alarms. A whisper in numbers, saying, "We were here." So far, no such code appears. The spectra shows strong carbon dioxide, weak water. Strange, but not impossible. The coma behaves exactly as solar physics predicts. No prime numbers, no constants hiding in plain sight. And yet every new observation forces the question, if chemistry could speak, would we even recognize the language? Maybe Atlas is just what it seems, a fragment of alien geology, not alien design. But speculation survives where silence remains. And in that silence, chemistry might be more than frozen matter. It might be the script of a message written in dust and ice, waiting for us to learn how to read.
Yet speculation refuses to vanish, because the quiet of space leaves room for wonder. In that emptiness, chemistry could be more than frozen gases. It might serve as a language, an alphabet written in ratios of ice and dust, waiting for someone to decipher it. There exists a theory whispered among astronomers and honed in the realms of science fiction, a theory as chilling as the void between stars. It is called the dark forest. Its premise is simple, stark, and terrifying. The universe is a forest at night, and every civilization moves like a hunter, silent among the trees. To announce yourself is to risk destruction. To stay hidden is to survive. Here, silence is not absence, it is a strategy. As Atlas drifts through the solar system without a sound, it may indeed be nothing more than a comet, a frozen remnant from another star's nursery. Yet the stillness is unsettling. No signals, no unusual emissions, no intentional maneuvers, just the soft glow of a coma and the predictable sweep of a hyperbolic orbit. Everything points to natural behavior. But if the dark forest idea holds, then silence is exactly what one should expect from intelligence patient enough to endure eons. Consider for a moment that Atlas is not just a comet, but a probe. Its goal would not be to broadcast, not to shine with radio beacons, not to demand attention. Its purpose would be to observe quietly, to blend seamlessly with the universe, and to record without revealing itself. In a cosmos where survival hinges on secrecy,
the riskiest act is to speak. For decades, humanity has scanned the skies for artificial signals, narrowband transmissions, anything to break the silence. We've sent messages in return, Pioneer plaques, Voyager golden records, whispers into the void hoping for a listener. But if the forest is truly dark, these may be less greetings than flares, announcing our location to predators we cannot yet imagine. Atlas may indeed be nothing more than ice and rock, shaped by gravity and time. Yet its presence forces a question. What if the gravest threat is not collision or invasion, but observation? What if our world is already catalogued, already noted in the logs of intelligence that never needed to speak? The dark forest offers no answers, only tension, the kind that arises when silence itself feels dangerous. As Atlas drifts around the sun and begins its departure, it may indeed be nothing more than a comet, a frozen remnant from another star's nursery. Yet the stillness is unsettling. No signals, no unusual emissions, no intentional maneuvers, just the soft glow of a coma and the predictable sweep of a hyperbolic orbit. Everything points to natural behavior. But if the dark force idea holds, then silence is exactly what one should expect from intelligence patient enough to endure eons. From the start, astronomers have insisted Atlas poses no threat to Earth. Its hyperbolic trajectory is precise, its closest approach hundreds of millions of kilometers away. It will not strike. The mathematics are absolute, comforting in their certainty. Celestial mechanics does not lie. And yet, even with this reassurance, a different unease creeps in, one born not of physics, but of imagination. We are conditioned to fear impacts. The scars of past collisions are etched across our planet, from the Yucatan crater that ended the age of dinosaurs to the Tunguska blast in Siberia. Hollywood has reinforced that fear, filling screens with fiery impacts and last-minute rescues. So when a comet appears in headlines, the mind leaps to catastrophe. Atlas's discovery was no exception. Even before precise orbital paths were calculated, the question arose, is it coming for us? The answer is firmly no. The numbers tell a story of safety, a visitor passing silently, returning to interstellar night. Yet the absence of physical danger does not erase psychological unease. Equations may close the door on collision, but they open another on uncertainty. If not destruction, then meaning. If not impact, then meaning. Here, imagination stretches farther than gravity ever could. A rock and ice body that brushes too close is terrifying in the obvious sense, but one that passes safely, merely drifting through, unusual, alien, inexplicable, invites a subtler, stranger unease, one that lingers. We are safe, yes, but safety is not the same as comfort. The psychological weight of Atlas lies not in extinction, but in the confrontation with the unknown. It is the third confirmed interstellar visitor, a class of objects so rare that each arrival reshapes our understanding of the galaxy. It moves faster than its predecessors, carries chemistry stranger than anything previously cataloged, and comes from angles suggesting origins in ancient stellar populations. These facts are not physically threatening, but they tug at a deeper human unease, the awareness of how little we know, how much may remain hidden in the cosmic dark. The collision never comes, Earth spins on. Life continues under skies that will never ignite with impact fire. Yet in that safety emerges a subtler disquiet. If Atlas is not here to destroy, why is it here at all? The threat is not mortality, but observation, to be watched, to be studied, confronted with a reality stranger than our imagining. We are safe, yet uneasy, protected, yet unsettled. The danger is not in numbers, but in silence. If the calculations are correct, Atlas may have wandered longer than the solar system has existed. Its speed, trajectory, and composition all point to origins in the thick disk of the Milky Way, a population of stars formed when the galaxy was young and violent. This makes Atlas not just old, but primordial, a relic from a time when the cosmos itself was still forming. To call it old is understatement. If it truly formed 10 to 12 billion years ago, it predates Earth, the sun, every ocean, every living thing. While our planet was still a cloud of dust and gas, Atlas was already moving, already exiled, already on a path that would eventually bring it here. To us, it seems sudden, urgent, immediate. To the comet, nothing is sudden. Its journey spans geological ages, relentless and uninterrupted. This provokes the question astronomers and dreamers alike ponder: what launched it? Natural answers abound. A giant planet in a long-dead system could have given it a gravitational shove. A close pass by a wandering star could have flung it into interstellar space. Over billions of years, gravity acts slowly. One encounter is enough to cast an object forever adrift.
And yet, when we layer this natural picture with shadows of speculation, the enigma only deepens. If Atlas is truly an ancient wanderer, what else existed when it began its journey? Entire civilizations could have risen and vanished in the time it has traveled, leaving behind nothing but silence. What if its journey was not a random ejection, but a deliberate launch? A probe, a vessel, a seed cast across the stars by minds so old that their worlds have long since faded. Seen this way, Atlas is more than a relic of galactic history. It could be a message in a bottle, drifting not only through space, but through time, carrying intentions that may now be indecipherable. Even as ice and dust, its age alone makes it remarkable. We are observing material forged around a star that may no longer exist, chemistry shaped in conditions that stretch the limits of our models. Every spectrum we collect, every image we process, becomes more than data. It is a conversation across billions of years. We ask questions into the void, and though the answers arrive only as faint chemical signatures, they speak of places and eras we will never visit. An ancient relic has arrived on our doorstep. Whether its arrival was accidental or guided by intent, it carries the weight of deep time. Watching it drift past reminds us how brief our own story has been, and how many others the universe may yet conceal. Now, imagine technology so advanced, so enduring, that it outlives the civilization that built it. Machines continuing their mission long after their creators are gone, wandering across the galaxy where the voices that gave them purpose have fallen silent. This is the unnerving possibility some ponder when they look at Atlas. What if it is not merely rock and ice, but ghost technology, still moving, still functioning, following instructions left billions of years ago by hands that will never touch it again? The thought is nearly impossible to hold in its entirety. Even our most advanced spacecraft are fragile. Decades in space reduce them to silence. Circuits fail, power fades, trajectories betray them. But what if another intelligence solved the problem of time itself? What if they built machines meant to last not centuries but eons, sturdy enough for interstellar travel, patient enough to persist even when no one remains to observe? In that light, Atlas becomes more than a comet. It becomes an emissary of ghosts. If engineered, its disguise is perfect. It sublimates like a comet, reflects sunlight like a comet, follows orbital mechanics like a comet. But underneath, perhaps something more resides, a system so advanced it can flawlessly imitate nature. Its silence would be strategy, not absence. The ideal probe is the one that goes unnoticed, blending seamlessly with cosmic debris while quietly observing, recording, persisting. And then comes the more haunting thought. What if its makers no longer exist? What if the civilization that launched it succumbed long ago to cosmic hazards, war, scarcity, collapse, or the unforgiving passage of time? Atlas would then be an orphan, a machine stripped of context, following programs intended for an audience that no longer exists. This shifts the focus of speculation. The concern is no longer threat, but legacy. Ghost technology would show that civilizations can achieve the extraordinary, solve engineering feats beyond our grasp, and still vanish without a trace. It suggests the galaxy might be strewn with remnants of intelligence, silent machines performing missions whose purpose has been lost to time. Even without its creators, such a machine would speak. Its endurance across billions of years would testify to the existence of intelligence elsewhere, proved not in words or signals, but in persistence itself. If Atlas is merely natural rock and ice, it is extraordinary for what it tells us about galactic chemistry. But if it is ghost technology, it is extraordinary for what it tells us about ourselves, our future, our fragility,
and the possibility that one day, long after we are gone, our own creations may wander alone through the darkness. The most unsettling visions of Atlas do not involve collisions or cosmic destruction. They involve silence, patience, and strategies unfolding over timescales beyond human comprehension. Picture this object that looks like a comet, behaves like a comet, passes through a solar system exactly as a comet should, yet inside its icy body hides something else. Microscopic devices, dormant seeds, or self-assembling systems designed to wait. Waiting is the key, not minutes or years, but centuries, perhaps millennia. This is the essence of the silent invasion scenario. No ships blotting out the sky, no alarms, just dust and gas drifting into space, indistinguishable from normal comet outgassing. Inside that dust could lie microseeds, tiny machines, or engineered organisms so small they evade detection, so resilient they survive cosmic radiation, so clever they know when to awaken. What triggers them could define their intent. Perhaps they respond to the electromagnetic signature of a technological civilization, perhaps to changes in atmospheric chemistry, activating only when a world reaches a certain stage of development. The brilliance of such a strategy is its subtlety. No dramatic entrances, no alerts. The seeds ride comets and asteroids like spores, most never landing on a hospitable world, most planets untouched. But all it takes is one success, one planet ready, and the waiting ends. Skeptics argue the odds are almost impossible. Deep space radiation would destroy complex molecules over billions of years. Outgassing could scatter fragile structures. Even if some survived, the dilution across the vast emptiness would make success extraordinarily rare. Yet in speculation, impossibility is irrelevant. The point is imagining what patience paired with advanced technology might achieve. The silent invasion concept is chilling in its elegance. It reframes threat as something patient, subtle, and timeless. A strategy that does not need to announce itself, does not act within human lifetimes, but unfolds over eons.
If Atlas carried such a system, it could pass through a solar system, leave no trace, and continue on its path. Decades, centuries later, the seeds might awaken. By then, the memory of this interstellar visitor would have faded, its trail cold, its passage recorded only in textbooks rather than active tracking logs. Yet its legacy could remain hidden, in soil, in air, in oceans. This is speculation layered upon speculation, yes, but it captures something fundamental about our fears. The most dangerous invasions are not the ones announced with fanfare. They are the ones we never see coming, the ones that already occurred while we were still marveling at the skies. Every calculation suggests that small bodies shouldn't last this long. Comets, fragile assemblages of ice and dust, are inherently ephemeral. They fracture under tidal forces, erode from solar heating, and break apart upon collisions with cosmic debris. Over millions, let alone billions, of years, they should be scattered into particles, fading into the background of interstellar space. And yet, Atlas persists. A body perhaps only a few hundred meters across, no larger than a modest mountain, has survived a journey stretching back to the galaxy's earliest epochs. The question presses against the limits of what seems possible. If its origin lies in the galactic thick disk, Atlas may have been traveling long before Earth existed. Over that time, it would have crossed dust-laden regions, endured radiation storms from supernovae, and brushed past the gravity wells of passing stars. Each encounter a potential catastrophe, each era of cosmic violence a chance for destruction. And yet it glows in the telescopes of 21st century astronomers, as though it were protected by some hidden hand. Natural explanations are persuasive but incomplete. Perhaps Atlas is simply tougher than most, its structure unusually compact, its volatile layers shielded beneath radiation-hardened crests, its density and composition placing it among the rare comets capable of enduring billions of years. Or maybe we underestimate the number of such bodies, countless ancient wanderers drifting through space, too faint for us to detect. In that case, Atlas is not a miracle, but a single example of a hidden population. Yet another thought lingers. What if its survival is not natural? Could endurance across galactic time require design, materials engineered to resist decay?
then Atlas might be less a comet and more a vessel in disguise, its battered shell concealing structures beyond imagination. A body built to last until it encountered something worth observing, or a probe meant to outlive the civilization that launched it, traveling autonomously, indifferent to whether any observer remains. This speculation exposes the uneasy divide between knowledge and fear. Natural survival is possible, yes, but design provides a simpler explanation. To endure this long, intact, and traveling so far suggests not accident, but intention. If intention lurks behind Atlas's improbable endurance, then its persistence is not just cosmic luck. It is a quiet signal, inscribed not in light or radio waves, but in the very fact that it continues to exist. Before Atlas, there was another visitor setting the stage for unease. In October 2017, astronomers at Pan-STARRS in Hawaii detected a faint, elongated object on a hyperbolic trajectory. Named Oumuamua, a messenger from afar, it arrived first. Unlike any comet or asteroid observed before, it carried scientific puzzles and a sense of mystery, as if we glimpsed something beyond comprehension, then lost it too quickly to be sure. Astronomers initially tried to categorize it. A comet? It had no visible comma, no tail of dust or gas. An asteroid? Its brightness varied in ways suggesting an extreme, elongated shape, perhaps 10 times longer than wide, like a cosmic shard. Then came subtle but undeniable acceleration. Oumuamua's trajectory shifted in a manner gravity alone could not account for. Usually such shifts come from outgassing, yet with no coma or emissions, the explanation seemed incomplete. The mystery deepened when calculations revealed its pre-solar system velocity. Like Atlas, Oumuamua was unbound, its eccentric orbit greater than 1, sending it forever outward into interstellar space. Observations lasted only weeks before it slipped beyond our telescope's reach. Those brief glimpses fueled years of speculation, debate, and unanswered questions. Some argued Oumuamua was natural, a fragment of a shattered planet, or an icy body stripped of volatiles long ago. Its acceleration could result from gas too faint to detect. But others, such as Avi Loeb from Harvard, suggested something more unsettling. Perhaps it was not natural at all. Perhaps it was alien technology, a solar sail, a probe disguised as debris. Since then, debate has never fully settled. Oumuamua remains a ghost, data incomplete, mysteries unresolved, but it left an enduring impression, the unsettling possibility that some interstellar objects are not accidents, but intentional. So when Atlas appeared, faster, brighter, chemically stranger than its predecessors, Oumuamua's shadow loomed. Every claim of natural origin recalled that first enigmatic visitor. Every anomaly invited whispers of deliberate intent. Atlas is not Oumuamua, yet in its mystery, it inherits the same haunting question. What passes through our solar system unseen, and what do we fail to recognize until it is gone? Then there was 2I Borisov, detected in August 2019 by amateur astronomer Gennady Borisov in Crimea. It arrived like a reassuring messenger, a reminder that some interstellar visitors follow predictable paths. Calculations confirmed it too was unbound, a comet traversing our solar system. But unlike Oumuamua, Borisov presented no strange anomalies, no hidden peculiarities. It behaved exactly as a comet should. Through telescopes, its bright coma unfurled, a hazy envelope of dust and gas blooming as it neared the sun.
Its long tail trailed behind, glowing faintly against the void, a delicate signature of sublimating ices and familiar physics at work. Observatories around the globe captured spectra that confirmed what the eye already saw: water, carbon monoxide, and other well-known molecules. These were the hallmarks of a frozen body responding to sunlight. Unlike Oumuamua, which forced scientists into speculation and conjecture, Borisov spoke in a language already familiar. There was something quietly reassuring about this visitor. It confirmed what models had predicted. The galaxy should be full of such wanderers, icy fragments cast out from young planetary systems by the chaotic pull of gravity. If Oumuamua inspired doubt, Borisov settled it. These objects exist, they pass through, and at least sometimes they appear exactly as expected. Astronomers observed Borisov with renewed focus, determined not to let this opportunity slip. Hubble turned its gaze toward the interstellar comet, capturing images of a nucleus veiled in vapor.
The Atacama Large Millimeter Submillimeter Array in Chile measured its outgassing, revealing a composition strikingly similar to long-period comets from our own solar system. Even the European Southern Observatory's Very Large Telescope recorded polarimetric data showing dust grains as familiar as they were unremarkable. In every measurement, Borisov reassured us. It was natural, ordinary, understandable. Yet ordinary did not mean insignificant. Borisov offered clarity that Oumuamua could not, a control case against which all other interstellar visitors could be compared. Its behavior suggested that icy wanderers are not unique to our solar system, that the processes shaping comets operate across the galaxy. Its chemistry hinted at diversity, but nothing truly alien. It was born in another star's nursery, yet kin to the comets orbiting our sun. In many ways, Borisov was the calm between storms, arriving after Oumuamua's enigmatic departure and before Atlas's unsettling approach. It offered reassurance. Sometimes the galaxy's wanderers are simply natural debris, not emissaries, not enigmas. But perhaps that clarity was an illusion, a lull that made Atlas's arrival, impossibly fast, chemically strange, and possibly older than our solar system itself, all the more jarring. Atlas demanded more than observation. It demanded interpretation. Was it an outlier, the product of extreme cosmic conditions, or something more deliberate, an intentional messenger cloaked as chance? Its speed alone distinguished it. Oumuamua impressed. Borisov was familiar, but Atlas surged inward with a hyperbolic excess velocity of 61 kilometers per second, nearly double that of its predecessors. Speed implied energy, and energy implied history. To reach such velocities required either violent ejection from its birthplace or countless gravitational slingshots across galactic time. Each scenario carried weight. Violence suggested chaos, a world torn apart and scattered. Accumulation suggested endurance, an object drifting long enough to gather the subtle pushes of stellar encounters. Either way, its speed marked it as extraordinary. Then there was the chemistry. Where Borisov offered comfort with familiar water and carbon compounds, Atlas confounded expectation. Infrared spectroscopy revealed a coma dominated by carbon dioxide, in ratios unlike any comet in our solar system. Its molecular fingerprint spoke in a dialect barely recognizable. Natural explanations, formation near a CO2 snowline, hardened crusts, insulating layers, were plausible, but none erased the strangeness. This was chemistry from another neighborhood entirely, and a sample of conditions from a distant stellar nursery utterly unlike our own. Age added to the mystery. Its trajectory suggested origins in the galactic thick disk, implying it may have traveled for billions of years, long before Earth had oceans. Atlas carried with it the memory of a younger Milky Way, a galaxy in violent, star-forming bursts, a time when chaos dominated and order had yet to emerge. Less than a comet, than a time capsule, it drifted through epochs we can only model and imagine. Viewed together, the three interstellar visitors create a narrative resistant to easy interpretation. Oumuamua whispered mystery, Borisov spoke clarity, Atlas shouts strangeness. Faster, chemically alien, ancient. The interpretation may reveal more about us than about it. We seek patterns, fear silence, and wonder whether chance can explain such anomalies. Perhaps Atlas is mere cosmic debris, remarkable only because we noticed it. Or perhaps it is a messenger, not literally designed by aliens, but a reminder that the universe does not conform to expectation. Sometimes the message is simply that we know very little beyond our star. At first, Oumuamua seemed a rare, fleeting visitor, gone before we could study it fully. Then came Borisov, arriving so soon afterward that astronomers began to suspect interstellar objects may be more common than realized. And now Atlas, discovered not by chance, but through expectation, poses the unavoidable question: why are we seeing more of these visitors now? Has the galaxy suddenly sent its wanderers our way, or have our eyes simply become sharper? The truth may lie in our instruments, not the heavens. Telescopes have grown sharper, surveys wider, and computers faster at sorting the endless flow of starlight. The Vera-Rubin Observatory, once fully operational, promises to expand this revolution further. Every generation of tools peels back another layer of invisibility, revealing that what once seemed rare may always have been here. Interstellar objects passing unnoticed, their fleeting visits lost in the background of stars. The cosmos has not changed. Our ability to perceive it has.